Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. In our Energy Talks podcast series, we have covered the benefits of using artificial intelligence, or AI, for effective data analysis and decision-making in power systems. For example, in our episode number 80, I spoke with my guests Florian Fink and Juan Carlos Sanchez about improving power grid reliability with artificial intelligence. This continues to be a very current and important topic for power utility companies worldwide. In this episode of Energy Talks, my guest is Vic Chowdhury. Based in Palo Alto, California, Vic is the co-founder, chief operating officer, and chief technology officer at Buzz Solutions, a global provider of proven visual intelligence solutions used to inspect, maintain, and secure energy infrastructure. Vic recently approached us to be an expert guest on Energy Talks to share his insights into the transformative and highly effective ways that artificial intelligence, or AI, and computer vision can and are being used to handle big data and greatly optimize predictive analytics in the energy sector. Vic will talk about the challenges faced by electrical utilities in managing their changing and expanding infrastructures and the importance of adopting AI and computer vision as a logical next step to meet these challenges. Vic will also describe how he and his team at Buzz Solutions are currently helping power utility companies bridge the gap between data and the insights that can be gained to help them cut costs, accelerate time to maintenance, and reduce the risk of grid infrastructure failure. Using actual case studies, Vic will highlight how AI and computer vision are being applied in the energy sector and offer practical tips for implementing them effectively and with greater confidence in power utility companies. So without further delay, I welcome Vic Chowdhury to this episode of Energy Talks. Vic, thank you for joining me.
Hey, Scott. Good to be here.
Thank you for reaching out to us to be one of our guests. This is going to be a very interesting episode. Vic, please tell us about your background and involvement in the areas of artificial intelligence, computer vision, and predictive analytics.
Yeah, no, Scott, happy to share some of the work we're doing. Happy to share my background as well. I'm co-founder and CTO and COO at Buzz Solutions. My background comes from the technology domain. I come from a background in AI, ML, data science, but that being applied to the power engineering, power systems, energy engineering. Prior to launching Buzz in 2017, I was leading AI and ML teams at Cisco for a few years, then got back to my energy roots and pursued a postgraduate degree at Stanford. I wanted to apply those kind of cutting edge technologies at that time to the power engineering sector, specifically in areas like smart grid technologies, DERs, those kind of use cases, which were coming up a lot at that time. Stanford's really great at helping their students combine various disciplines. So I combined power engineering and energy engineering with data science, cutting edge computer science technologies. And then after my degree, I got involved with Buzz Solutions. So decided to launch this company out of Stanford University with my co-founder. The genesis for that initially was we were part of an entrepreneurial launchpad course at Stanford where our skills were complementary, and we met in the launchpad course and decided to, do something and apply this cutting edge technology for the energy sector that was kind of coming up, needed some infusion of technology at that time. So we started exploring the use cases. At that time, was running a project that we were using drones to inspect wind turbines. And that at Stanford, that was part of my thesis. So some of the idea came from that. But then we started talking to power utilities and they told us, why don't you apply this technology for the power sector? And that was kind of the genesis of Buzz Solutions.
Excellent. Well, before we talk about Buzz Solutions, I'm very curious to know, what is your background in the energy sector? Had you worked in that sector before?
I have not. I was pursuing a lot of energy engineering courses at Stanford. And as I explained, one of the projects was with drones to inspect wind turbines, optimize the location of wind turbines. That project thesis was actually sponsored by ARPA-E and PG&E at that time. So that was mainly my involvement with any kind of energy research at that time. But then my previous background has not been working with power utilities. I was always fascinated by the work they do, and I always wanted to help power utilities. when I got into this sector, just wanted to bring that new cutting edge knowledge to help power utilities and the power sector in a much more positive manner.
Very good. So now tell us about your company, Buzz Solutions. You mentioned it was founded in 2017. Where are you located? What is your company's mission? And what types of customers do you work with?
Yeah. So Buzz Solutions, you're right. We were founded in 2017 by me and my co-founder, Caitlin Albertoli. And we were founded out of Stanford University in Palo Alto, California, at the heart of Silicon Valley. This is a classic story, but our mission was when we were launching this, we want to start off with a technology company, but we want to tackle a problem that is in the energy sector, which was still applying antiquated technologies. And it was at the cusp of, looking and scoping out newer technologies. Our mission was to help an industry that needs positive infusion of technology. Based in Palo Alto, California, we're a team of 35 people, fully remote in the United States, spread out, and it's been working out great for us.
Very good. Tell us about the growing demand for AI, computer vision, and predictive analytics. Why are these technologies becoming increasingly important for the electrical power industry?
Yeah, so electrical power utilities and industry are at a very complicated point right now where they're facing a lot of problems on the infrastructure specifically. You have increasing amount of load demand, you have workforce that's retiring, you have supply chain issues, you have climatic conditions and extreme climate factors that are impacting the infrastructure in a much more stressful way. And this infrastructure is mostly the grid network, so your power lines, but also your generation, so your substations, your solar panels, wind turbines, renewable generations, and conventional generation facilities as well. They are at that place where, conventional methods that they've been following for decades just are not doing the right thing for them. What they're trying to do is inspect this infrastructure much more frequently. So now they're deploying drones, cutting edge drones with high resolution cameras, helicopters, aerial vehicles, and then doing much more frequent inspections. The problem that they are having is this massive amount of data from these inspections is still manually analyzed. And as you can imagine, millions and millions of data points manually analyzed cannot be done in a very time-effective, cost-effective way. So they're struggling to manage all this data. That's where big data automation, AI, analytics, data science has been a really big catalyst to take in all of that and then make sense out of it. That's where we're trying to play.
I assume when you're handling this information manually, you also have the phenomenon of data silos where information critical to know about is isolated within the organization. So you mentioned a number of the challenges that the utilities are facing, which are making such new technologies very attractive to implement. What are the typical power utility applications that are ideal for these new technologies?
Yeah, so there's a lot of applications that utilities are deploying these new technologies, whether it's IoT sensors for more data collection and monitoring, drones, which are, we can consider them as mobile sensors. So they're flying, they're collecting data because they have visual component or cameras with it. So they're collecting visual data. And then beyond that is your data science, your AI models, your machine learning models that are being deployed for various kind of applications at power utilities now. One of the biggest ones that where we are helping is the visual infrastructure inspections. Imagine a utility in a year, they have thousands and thousands of miles and kilometers of their power lines. And with that, one of the utilities that we've talked to, they collect 20 million images on their infrastructure every year. So that's a lot of data. That's terabytes and terabytes of data that they have to manage. And Scott, you hit one point really accurately, which is data siloing is also a big problem. So, there's multiple teams at utilities, whether it's GIS, it's operations team, maintenance team, and all this data is kind of scattered. So one problem that they're facing right out the bat is how can we manage all this data so that we can ideally after that make sense out of it. All this big data needs to be managed, which can be managed through enterprise level cloud deployments. Once that data is managed, that's where they can get more fancy and apply more fancy, sophisticated analytics, which is where the AI models kick in. The area we play in specifically with utilities is a specific niche area called computer vision or machine vision, which basically takes into account images, videos, any kind of visual data points, takes those in, manages it, and then processes it. It basically picks out any kind of information from the images. And as people say, a picture is worth 1,000 words. It can actually derive so much information. For example, let's say utility captures a pole. From the pole, our systems or computer vision systems can find out whether the pole is broken, whether the equipment, electrical equipment on the pole is damaged. And even if there's overheating in the pole with thermal imagery, we can find what kind of electrical components like transformers or insulators are getting overheated that can lead to sparking. All of this information then is extracted from all of this data, which becomes information for utilities, but we go one step beyond, or these AI systems go one step beyond, which is making this information actionable. So linking this information with GIS systems, with asset management systems, with work order management systems. And all of this saves a lot of time and cost for utilities, but on a grand scale, it also helps utilities to prevent disasters like power outages, blackouts, and even in extreme conditions, wildfires caused due to failed grid infrastructure.
How are you helping the utilities process this information? Are you consulting them on how they set up systems that will enable them to work with these tools and to effectively process all the data?
Yeah, no, that's a great question. So we deploy software platforms. We are a full software company with AI computer vision at its core. We deploy a software platform from our side for utilities so that they can manage their visual data. They can process, analyze that visual data with our proprietary computer vision AI models. And then they can derive insights from it and then integrate those insights into their workflow systems, whether it's GIS systems or asset management systems or work order management systems, with the sole purpose of getting their maintenance teams the right amount of information so that they can go out in the field faster, more frequently, and now they know what they're looking at. We're giving them the information which can be actionable. So what kind of problems happening, where it's happening, and what can they do about it. So that's a lot of, insight and impact for them in terms of what value we deliver. We do consult utilities also. If a utility comes to us and say, hey, we want to, inspect our infrastructure in a much more efficient, much more optimized and safer manner, what can we do about it? So we'll consult them, what kind of drones they can use, how can they do inspections in the best way so that the AI gives them the best results. We can also help them set up the whole infrastructure imagery program. We are putting out a lot of how-to guides on how to do that. And this is mainly for educating the industry. What are the best practices for doing it? So more for educational purposes. For example, how to evaluate AI for infrastructure inspections, how to know when you're ready for AI and software for infrastructure inspections, and then how can you scale your AI programs for this. All of that knowledge we're providing to utilities.
How do you see the willingness to adopt these new technologies in this sector? How are you helping companies really see the true benefits of it and to take away some of that fear of adopting new technology so quickly?
Yeah, no, that's a great question. And that's an age-old problem with utilities. They're slow moving, right? So when we started the company, we saw that utilities are slow in adopting new technologies. They're risk averse. And eventually we got to know why, because, there's lives at stake. If you deploy a technology that's not heavily tested, piloted and then validated and then deployed in the right way, your power infrastructure go down and there's lives at stake for that. So utilities are at the front lines of dealing with all of this stuff. We wanted to make sure that the technology that we deploy for utilities is heavily validated. So early on, we worked with research organizations like Electric Power Research Institute, EPRI. We worked with multiple utilities, piloting and doing proof of concept over the years so that they become comfortable. And then in the last few years, I think we have seen a change where utilities are becoming much more open to new technologies and funding new technologies and funding startups that are deploying new technologies. There's more innovation teams getting set up at utilities that are primarily focused on that. And even utilities have started doing a lot of like in-house funding engines or financing engines. A lot of utilities have venture arms now that can fund startups or newer companies and newer technologies so that with the sole purpose of growing those technologies to a way that utilities can deploy it in a much more efficient manner. So we are starting to see a lot more change. It is slow, I would say, but it is moving the right direction. Utilities are realizing that they need to adopt new technologies to solve these really complicated issues that they're facing.
Very good. Do you have any examples of how adoption is taking place in the industry? Do you see the technologies already optimizing and shaping the future reliability and efficiency of power grids?
Yes, certainly. We have a few major clients of ours that are already using our technology at scale. We have done projects. Most of the projects have been in United States, but we have done projects in Canada with Canadian utilities. We have done a few projects in South America, and we're getting a lot of interest from South American utilities recently because they've skipped the phase where they're looking at United States utilities, and they've skipped the phase of where there was a holdup, and now they're directly going to technologies like drones and AI, which is great for them. So they got a head start. We've done a few projects in Europe as well with some European utilities, but most of our customer base is in the United States. One of the biggest customers that we have is Dominion Energy. They're based in on the east coast of the US, and they have a lot of infrastructure. And we've been working with the transmission team. And I'll give you an example, working with the transmission team to analyze their transmission towers and make sure that they're up to par where there's maintenance required. And one example is recently we analyzed around, almost 100,000 images within 10 hours, for which would have taken them a year or more to manually analyze. So that's one example where AI is working at scale, delivering these insights so fast and then in a prioritized manner, that the utilities can leverage this information and get out in the field and do proactive maintenance. So going from time-based maintenance to more condition-based and proactive maintenance is the key for utilities. And we are trying to help enable them with that. And then we're following the same kind of workflow for other utilities in the US as well. We have multiple other utility customers. And one of the great things is with utilities, once you deploy, and since this is a new technology, this is new adoption. Once you deploy successfully with one utility, you can try to replicate with other utilities, geographically in the same region or who are facing the similar kind of problems. And we're trying to do that.
Very good. Now, it's very interesting what you say. You are taking a lot of work off the shoulders of utility companies, maintenance teams, who normally manually processed visual images and data to understand the condition of their assets and to understand the functionings of their infrastructure if there's a problem where. Tell me how AI is able to do that automatically. For example, with visual recognition of problems, how do you teach a system what to look for?
Now, that's a great question. And that's one of the challenges also when we started developing this technology. One of the key challenge in this domain is AI needs a lot of data. Data is the fuel for AI and machine learning models. Without data, you cannot build any model. You can have the best model architecture, but if there's no data flowing into it, then nothing is going to come out. One popular saying is, garbage in, garbage out. So you need to put quality data in order to get quality outputs or quality results from the other side. What we started doing was, and one of the challenges early on was utility data is very proprietary. It is critical infrastructure data. It's not available in public domain. There's lack of that kind of data for any kind of company to come in and start building models. So you have to build those relationships, those partnerships with utilities, which we did early on in our early years of the company. We took 2.5 years to build these proprietary models to a high degree of accuracy. And now we are leading with our accuracy metrics, the capabilities that we're detecting, the kind of components we're detecting to a high degree of accuracy levels for utilities. So that took a whole process for us. And then the way we are training the models is we take a lot of data in. We have developed subject matter expertise in-house now, but we sat down with utilities. We understood, what are their pain points. We were listening to the customers when we were developing our product. If this is a good component, how does this component break? What are the failure modes or methods for the component breakage? Once we get that information, we transfer it to the machine for the machine to understand it. And once the machine understands, we still have to test it out with real world examples. And in a lot of cases with AI, there's data drift or model drift that can happen eventually. Is you can deploy a 95% accurate model in the field, and eventually over time, that model can start hallucinating or drifting, which means that the accuracy levels will decrease because one of the reasons is the data coming from the field has changed. So we had to make sure that we were building in processes to kind of always tuning and retraining the model so that they are healthy, they're always learning, and they're becoming personalized for these utilities.
Very good. This is so fascinating. What trends do you see in the industry that will make the implementation of these new technologies increasingly essential?
Yeah, there's a lot of trends happening, and a lot of those trends are driven by challenges in the industry. So I'll highlight, some of the challenges On the infrastructure side, there's more extreme climatic events happening. Areas that were hot are becoming hotter, drier. Areas that were having these storms are more extreme. We're talking about hurricanes, massive storms on the southeast and the east coast. We're talking hot and dry weather, extreme weather on the west coast, and which causes wildfires. As you can imagine, all of this infrastructure is out in the open. It's facing the stress from the external factors, extreme climatic conditions. The second one that kind of enhances that is the grid or the network or the infrastructure is facing challenges from internal factors, which is increasing load demand. We're talking about AI and data centers. Data centers are driving the load demand for utilities. Electrification efforts, electric vehicles, they are driving the load for utilities quite a bit. And it's kind of estimated that the load growth demand, especially in the US, is going to be twice or thrice in the next 5 years because of the immense amount of data centers which drain electricity and power. In a way, it's a closed loop that AI is driving the load, but also AI is also trying to solve those challenges for utilities. These complicated challenges need really innovative solutions. Utilities are trying to deploy more IoT sensors so that they can monitor more. They're trying to inspect the infrastructure in a much more frequent manner, so generate more data. And not just for infrastructure, they are also trying to generate data on like the customer side of things, on the distribution level, at the substation level. The more data that they can have, the better picture they will have for the infrastructure and other kind of applications. And that's where once they have the data, that's where AI comes in to solve the challenges of, load growth. Supply chain issues is another challenge that utilities are facing with components degrading. As you can imagine, the grid is under so much stress and strain. The electrical components, their shelf life decreases because of that. And this is a supply chain issue for delivery of these components. They have to make sure that these components are up to speed, up to par all the time, repair, replace, maintained at the right time. So a lot of trends are happening in that sense. Cutting edge technologies, in my opinion and my peers' opinion, is going to be the key or the solution for utilities because conventional methods that they've been following for decades are just not working out anymore.
Very good. And these new technologies are here to stay. And of course, they're going to become increasingly powerful and capable of handling all the work we're talking about that needs to be done. Do you have any tips or recommendations for power utilities to consider when implementing these new technologies? I would think that they would have to do a big cultural shift within their organization and understand the types of people they need to get it started to manage the process and to also work with consultants and other companies such as yours. That takes a while. So what would be your tips to help get companies, utility companies, up to speed as quickly as possible?
Yeah, no, that's a great question. Utilities are at a very, at a junction. They are trying out new technologies. There are vehicles for them to try out new technologies that were not available 10 years ago. A lot of utilities, as I said, have innovation teams and they work with research institutes like EPRI, Electric Power Research Institute, and EPRI has programs for enhancing and bringing forward new technologies through smaller pilots or proof of concepts with utilities. One of the tips for utilities is explore these programs because that way you can work with research institutes and validate in a pilot program a technology with a company that could be useful for you down the line. And once it's validated and the pilot goes in the positive direction, then you can implement it at a larger scale in your organization. So start looking out for these programs because they are available and they want to work with utilities at a low cost. So that's one of the things. Second thing is utilities need to be ready with data. And that's a great point you mentioned, Scott, is the culture shift or the mindset shift. So, and that happens with more education because there's still fear among people, not only just utilities, but general populace, is that AI is going to take away the jobs. And which is not happening in the utilities case. I think there's a lot of education, and we try to educate utilities as well, that AI is basically a tool for your workforce to manage their job much more efficiently, much more safely, and in a much more optimized manner. So the analogy I gave is for people before they were inspecting infrastructure, they were writing it down on their notepads. Then they changed to a digital interface, whether it's Word or Excel or any kind of software on the computer. And now AI is another tool or an advanced interface for them to interface with. One of the examples I gave is we have a tool called Human in the Loop or Inspector in the Loop, which is basically taking in subject matter expert feedback. AI does a first pass filter of doing the mundane task of analyzing all this, thousands of imagery, but then it's still the subject matter expert, which is the inspector, that would say, okay, this is good, this is not good, let's go over there. So it's still the power in the hand of the human. And it's basically human and machine working hand in hand to solve a really complicated problem. So understanding that, educating the industry and utilities on that is critical. We're trying to do that also. So I would say one piece where the mindset can change is more education about these technologies and tools, rather than just fear mongering on AI is going to take away jobs. So that's one critical thing. And then also utilities on the technical side have to become ready for data. The big data is coming. You have to collect more data to get more information and make better decisions out of that data. In order to do that, they have to implement enterprise cloud infrastructure programs, because conventional servers, they are at capacity. They cannot store this massive amount of data that comes in. You need to have cloud infrastructure that's scalable and deployed at enterprise level. Once you have figured that out, then you can build more sophisticated tools, analytics tools, decision-making tools on top of that. So cloud infrastructure implementation. But also with utilities, one of the key things is security, and specifically cybersecurity. So how can these tools be more cyber secure? Having that knowledge and working with utilities and the vendors or software providers, making sure they have the right compliance in place, they have the right cyber audits in place, right certifications, because this is critical infrastructure data. And utilities, I think, are one of the most heavily cyber attacked organizations. Cybersecurity should be of prime concern for utilities, and make sure those compliance methods are implemented at the highest level.
It sounds like this is a process that will just take its time to implement and to perfect over time so that it's really working. So I think the big message here is just to get started.
That's correct. Yeah, just get started. But before you get started, have a checklist, what you need. Make sure, those requirements. And one thing I would mention that I forgot to mention is how you measure ROI. It's great to deploy a cool technology that's out there, but if it's not delivering any business value or ROI, then what is the purpose of that? So calculating that is also the key for utilities. Find which vendors are out there, see what kind of work they're doing, what are their successes, maybe get involved in some research programs with these vendors, run some pilots, and then scale from there.
Could you tell our listeners where they can get more information about these new technologies? Is your company presenting anywhere? Do you have an active LinkedIn or YouTube channel where people can get more information?
We do. We are very active on our LinkedIn. It's Buzz Solutions on LinkedIn, and then our website as well, www.buzzsolutions.com. We also have mailing lists, newsletters that we update people, and you can sign up on our newsletters. You get all the updates where we are going to be at conferences and trade shows. We have a few coming where we'll be presenting. We're always on stages, presenting successful case studies from utilities that we have done projects with. Also educating the industry, which doesn't have to be a selling motion, right? We want the industry to rise together. We are putting out how-to guides on how to scope your problems. How do you know when the AI is the right fit? What is the ROI, and how can you calculate ROI with these AI programs? And then how can you scale the AI programs? And then one extra one is, how can you make sure you're cyber secure with these AI software deployments? We are putting out these how-to guides just for general industry education. They can be found on our website. We always run webinars as well. We're always happy to educate the industry and then also talk about what kind of work we are doing with utilities.
You have a lot of incredible things to say and promising things to say, encouraging methodologies that utilities can take on. I really appreciate you joining us. Thank you very much for joining me in this episode of Energy Talks and sharing your experience and insights on the use of AI, computer vision, and predictive analytics in the electric power industry.
Thank you, Scott. It was a pleasure. And I always say the discovery and invention of the power grid and the electricity was the biggest invention of the 20th century. AI is going to be the defining invention of 21st century and probably beyond. Everyone should pay attention to it and try to see where AI can fit to solve complicated problems.
Very good. Thank you again.
Thank you, Scott.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.